So welcome to this discussion on questions in previous question papers of JEE Advanced from Egan Learning. And let us have a question in organic chemistry in the paper 2 of JEE Advanced 2023. This is a question. In the following reactions, P, Q, R and S are the major products. Then we are given certain statements about the 4 products and we have to see which all statements are correct and which are not correct. So here again you have starting compounds and a series of reactions to come to the products P, Q, R and S. Let's start one by one. In the first compound, it is a tertiary alkyl group, tertiary butyl group at one position, and at the para position you have the CH2CH3 group. And what happens is, during the oxidation of this compound by alkaline potassium permanganate, as you know, is the reagent for carrying out the side chain oxidation, the tertiary butyl side chain remains intact. It is not oxidized. That's very important. The tertiary butyl group on a benzene ring is not oxidized by alkaline permanganate. It is stable. It is not oxidized. And it is the other group, that is CH2CH3, getting oxidized. And therefore, the product formed in the first case, the first reaction is, the product formed in the first reaction is okay, and you have the acid group. Here the carboxylic acid. And you know that in side chain oxidation, irrespective of the number of carbon atoms in the side chain is oxidized to carboxyl group, provided you carry out the oxidation with alkaline permanganate for sufficient time for the reaction to get completed. So this is the product obtained in the first step of the reaction. Of course, it is alkaline medium, so naturally the product formed will be the salt of the product, and on acidification, that is the second step, you will get the free carboxylic acid. So this is a compound P. Now in the second compound, there is a COCl group. You find a COCl group. There is an acid chloride group. And on the other side, you have a COCH3 group. That's a methyl ester, COCH3, an ester group. And the reaction is with alkali, that means hydrolysis reaction. Both the acid chloride and the ester group are derivatives of acids. So naturally on hydrolysis with NaOH, both the acid chloride and the ester group get hydrolyzed and you have COOH here and COOH here. And of course, in alkaline medium, it will be formed as a salt, but on acidification, you are given H3O plus, you will get the product COOH, and here you have COOH. So that is the product Q. It's again a dicarboxylic acid with acid groups of the meta positions. That is what you call isophthalic acid. If the acid groups are at the ortho positions, it is phthalic acid, and this is isophthalic acid. And if the carboxyl groups are at the para position, you know, it is terphthalic acid. In the IUPAC nomenclature, this will be called as benzene 1,3-dicarboxylic acid. So Q is benzene 1,3-dicarboxylic acid. Okay? Now coming to the third question, the third one. It is COCH2COCH3. That's again an ester group. It's an ester group. Okay? And at this side, you have the CN group, cyanide group. and it is acid hydrolysis. H3O positive, reaction with an acid. Okay, and heat, of course. And so what happens is the hydrolysis of the ester group to give COOH. The CO group is here, there's CH2, COOH, hydrolysis here. At the same time, the CN group is also hydrolyzed. You know that compound containing CN group is converted into COOH. The CN is converted into COOH by acid hydrolysis. And this compound, if you examine it, is alpha beta, it's a beta keto acid. And beta keto acids, as you know, are spontaneously decarboxylated, and therefore the compound formed will be this one, CO CH3, and here you have COH. Okay, and in the next step it is oxidation by H2CrO4, chromic acid oxidation, and if chromic acid oxidation, this part of the molecule gets oxidized and the product formed is COOH. That is a compound obtained by oxidation with chromic acid. The COCH3 part gets oxidized to carboxylic group, and therefore the product R is this one, which is again isophthalic acid with the two carboxyl groups on benzene ring at the meta positions. It is same as Q, but however in the equation given it is given the symbol R. It is denoted by R. So this is a compound R, this is a compound P, and this is a compound Q. And now is the last one, where if you closely look at the substrate molecule in this reaction, of course it is a bromobenzene unit here, and on the para position, if you very carefully look at it, you will see that what is present is CH2OH, CH2OH with an aldehyde function. So this something like a cyclic acetal O CH2 CH2O O CH2 CH2O. So it is a cyclic acetal of an aldehyde, of this aldehyde, that is para-bromobenzaldehyde. Para-bromobenzaldehyde with ethylene glycol. So that is the substrate. I repeat, it is the cyclic acetal of para-bromobenzaldehyde with ethylene glycol. That is the substrate. Okay? So that on reaction with the magnesium in dry ether medium, of course, at this part you have the Grignard reagent formation MgBr, and reacts with the carbon dioxide, then hydrolysis with H3O plus, you have the COOH group there. And during hydrolysis, this part, that is the cyclic glycol, the cyclic acetal part, that will also be hydrolyzed, and you will have the aldehyde group restored. Okay, so the product of the reaction will be the carboxyl group here, and at the para position you have the aldehyde group. The aldehyde group is regenerated at the para position. Formerly it was the cyclic acetal with the glycol, and now during hydrolysis that is broken away, and you have the free aldehyde group at the para position of the COOH group. Now this position you have the COOH group. Why? Because with the magnesium you have MgBr, with the carbon dioxide you have COOMgBr, and therefore hydrolysis gives carboxylic acid. So that is the product formed, and one more step is there, and that is the reaction with ammoniacal silver nitrate, that is Tollens reagent. And we know Tollens reagent oxidizes aldehyde group to acid group. So the final product formed in the reaction is COOH, and here you have COOH. So that is a compound S formed. The compound S formed in the reaction is the compound with the COOH groups at the para positions. So it is actually benzene 1,4-dicarboxylic acid, or what is called terthalic acid. So the compound P is para-tertiary butyl benzoic acid, and the Q is isothalic acid or benzene 1,3-dicarboxylic acid. R is also isothalic acid or benzene 1,3-dicarboxylic acid, and S is benzene 1,4-dicarboxylic acid or terthalic acid. So now the products are ready. So we can go through the statements. P and Q are monomers of polymers dacron and glyptol respectively. P and Q are monomers of polymers dacron and glyptol respectively. Of course, dacron is prepared from terthalic acid. So P has nothing to do with the terthalic acid. P is not a terthalic acid. So it is not the monomer of dacron. And glyptol is prepared from phthalic acid, 1,2-dicarboxylic acid, benzene 1,2-dicarboxylic, and therefore Q is not the monomer of glyptol. So the first statement is wrong. P, Q and R are dicarboxylic acids. Of course, P is not a dicarboxylic acid. P contains one carboxyl group and one tertiary butyl group. So it is not a dicarboxylic acid, and therefore the statement B is also wrong. Of course, Q and R are dicarboxylic acid, but P is not a dicarboxylic acid, and therefore the second statement is not valid. And coming to the third statement, compounds Q and R are the same. I already said compound Q is benzene 1,3-dicarboxylic acid, and the compound R is also benzene 1,3-dicarboxylic acid. Both are isothalic acids, and therefore the compound is Q and R are the same. So the statement C is correct. Okay? And the statement D is about R. It doesn't undergo aldol condensation. Of course, it doesn't undergo aldol condensation. R doesn't undergo because it doesn't contain any alpha hydrogen containing aldehyde or ketone. It's not at all a alpha hydrogen containing aldehyde or ketone. It's only a dicarboxylic acid. Therefore, R will not undergo aldol condensation. And yes, it is para-dicarboxylic acid of benzene, and yes does not undergo Cannizzaro reaction. So R does not undergo aldol condensation, and yes does not undergo Cannizzaro reaction, does not undergo Cannizzaro reaction are correct statements. Therefore, D is also a correct statement. Does not undergo aldol condensation. They are dicarboxylic acids, so they do not undergo aldol condensation or Cannizzaro reaction. R does not undergo aldol condensation, and S does not undergo Cannizzaro reaction. That's a correct statement. Okay? C and D are correct statements, whereas A and B are wrong statements. Okay? Again, a question from organic chemistry, but a lot of reactions are involved, and therefore it may take more time to answer such questions. But remember, the question is not at all complicated. It deals with only the fundamentals in chemistry of acids, esters, carbonyl compounds and all that. And of course, the fourth reaction here may slightly sound difficult because this group, one has to see that this group is the cyclic acetal of the aldehyde group with ethylene glycol. So this group undergoes a hydrolytic cleavage, forming the aldehyde group back. So you are getting the aldehyde group back. So para-bromo-benzaldehyde is a compound, but that undergoes a reaction with the magnesium and dry ether medium, Grignard reagent, and carbon dioxide. You have the acid group, and on reaction with ammonium silver nitrate, the aldehyde is also oxidized to the acid group. So the ultimate product in the fourth conversion is benzene para-dicarboxylic acid. So perhaps that will sound a bit difficult because of this cyclic, but apart from that, there is no difficulty in this particular question. You very cautiously and peacefully answer the question. I think you will get the answer for that. So thank you for listening. Okay.